Welcome to today's video. Today we're going to be focusing on finding missing angles and sides by using sine. And we're going to show that mastery in class by scoring at least an 80% on an exit ticket. Hopefully you have the notes in front of you. If you don't, take out a blank sheet of paper. That way you can take the notes and we'll get you a fresh copy tomorrow. Now, when it comes to sine, we're spending the next couple days on what we're going to call SOHCAHTOA. And you're going to hear me say that again and again. And it's just a little acronym to help you remember how to find missing angles and missing sides in right triangles. Today we're focusing on the first part, the SO. And our ratio is always going to be sine, which is my S, is equal to O stands for my opposite, and H stands for my hypotenuse. Now, if you remember back to when you did Pythagorean theorem, your hypotenuse is always the side across from your right angle. Well, it still holds true when we do sine, cosine, and tangent, or SOHCAHTOA. Your hypotenuse is always your longest side or the side across from your right angle. So if I look at my sine ratios, and when it asks for a ratio, it just wants our fraction. So if I'm doing the sine of A, well, if I start at angle A, I want the opposite. So if I look directly opposite from where angle A is, that's going to be 12. And my hypotenuse, which is always going to be across from my right angle, is 13. So the sine of A is 12 over 13, and we leave it as a fraction. If I look at the sine of B, my hypotenuse doesn't change. It's still across from the right angle, but now if I look at angle B and I want to go opposite from where it is now 5 over 13. Again, leave it as a fraction. We just want the ratio, and a ratio is just another way to say a fraction. Now, if we want to actually apply this and find missing angles and missing sides, first of all, and the first step always, 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 is you need to make sure your calculator is in degree mode. If your calculator is not in degree mode, it will still work, but it will give you the incorrect answer. So at the top of your calculator, press the mode button, which is next to second, and change it from radian to degrees. Now, when we solve for x, again, it's always SOHCAHTOA. So in this case, it's going to be opposite over adjacent. Well, if I look at my angle, x, if I look opposite it, it's 9, making 14 my h. So sine of x is equal to 9 over 14. Now, from here, normally we do our inverse operations. If we were adding, we would subtract. Well, the inverse of sine is actually going to be called inverse sine. And in your calculator, you're going to put sine negative 1 of 9 over 14. And if you notice your sine button, if you look above it, in blue, it says sine negative 1 or inverse sine. So you would hit the second button and sine. In this case, x is going to equal 40 degrees. If I look at number 4, again, if we label our sides, if I start at my angle, this is my O, making 30h my hypotenuse, and 38 is across from the right angle. I don't know my angle, so it's sine of x is equal to 31 over 38. Again, we want to do our inverse operations, which means we have to take inverse sine. Our fraction stays the same, 31 over 38. So then x is equal to 54.7 degrees. Now, if we look at finding sides, again, we still want to set it up the same way. We still want to use SOHCAHTOA. So if I look at my angle, that equals my O, making 17 my H, since it's across from the right angle. Well, I now have an angle, so I have the sine of 41 equals x over 17. In this case, we need to solve for x. Well, 17 is on the bottom, so I'm going to multiply both sides by 17. X is going to equal 17 times the sine of 41. And you can type that right in your calculator, giving you a total of 11.2. So my side x is equal to 11.2. If I look at the last one, again, we want to label our sides. This is my opposite side, and this is my hypotenuse. So now I have the sine of 73 is equal to, my opposite is 29 over my x. Now, in this case, if we were to do this, you'd multiply both sides by x, and you get x times the sine of 73 equals 29. Well, then we have to divide both sides by the sine of 73 because we want x by itself. So x is going to equal 29 over the sine of 73. And again, you can type that right in your calculator, which gives you 30.3, making my hypotenuse 30.3. And if we look, again, your hypotenuse always has to be your longest side. Well, if I look at my opposite is 29 and my hypotenuse is 30.3. It's not longer by much, but it is longer, so that can hold true as the value for the hypotenuse. Please bring your notes and any questions you have tomorrow to class. I look forward to seeing you then.